morning and welcome to Mr. Mickleburgh's Maths World. This is the way it is. Okay, today we are plotting quadratic graphs. And here's the graph we wish to plot. Y equals 5x squared minus 10x plus 2. It's important to know what you're up for before you begin. You need to define these four features of the plot, and then we go ahead and plot it. So the y-intercept, the x-intercepts, the axis of symmetry, and the turning point. I say x-intercept bracket S because with the parabola there's three possibilities. You might not have any x-intercepts. You might have one, which is not really an intercept. It's the x-axis will be a tangent to the turning point, but we call that one intercept really. Or more commonly, the one we'll be looking at today will have two intercepts. The axis of symmetry goes through the turning point, and it's an equation of the form x equals some number, and then the turning point we find after substituting the value for the axis of symmetry into the original equation. Okay, so the y-intercept is the easiest one, and we generally do that first. We let x equal 0. Now, that's easy because when you let x equal 0, you can see that what's going to be left standing is the constant term. Okay, so here we say by inspection that the y-intercept will be 0, 2. We write it as a coordinate. Okay? Alright, the next item on the agenda is to find the x-intercepts. We've got a choice of methods here. We could use the completing the square method, or we could use the quadratic formula. I'm going to use the quadratic formula, but what I'd ask you to do is confirm the result at your leisure by using the completing the square method. That would be good revision. Okay, so the quadratic formula, let me just write this down. You need to learn off by heart, is equal to negative b plus or minus b squared minus 4ac all over 2a. And it's important to identify what a, b and c are. A is the coefficient of x squared, so it's equal to 5. B is the coefficient of the x term, so it's negative 10. And c is the constant, which is equal to 2 in this case. Okay, so we substitute those values into our formula, and what we're going to find are the x-intercepts. Therefore, x equals negative b is negative 10, so that's positive 10, plus or minus the square root of, now remember b is negative 10 all squared is 100, minus 4ac, so it's 4 times a times c, so it's 4 times 5 is 20, 20 times 2 is 40, all over 2a, and a is 5 as we've seen. Okay, so therefore x is equal to, let's just leave that like that for the moment, over 60 over 10. Now that's a reasonably unsatisfactory way of presenting your x-intercepts. This surd can be simplified. Remember, the key to simplifying surds is to find a number that is a square number that is a factor of the number under the square root sign. So the best we can do there is to say that 60 equals 4 times 15, doesn't it? So 4 times 15, well, the square root of 4 is 2, so we take that out. Okay, you see how I got that? Square 2, you get 4. 4 times 15 is 60. All over 10. Now, what I can do here is tidy it up a bit. When you're dividing a fraction of that sort by 10, you can divide each number upstairs by the highest common factor. So it's 10 divided by 10 is 1, and then I have plus or minus 2 goes into itself once, and it goes into 10 5 times. So it's going to be the square root of 15 over 5. Okay, I divided that by 2 and I divided that by 2. Alright, that's x equaling that. So they're indicating my x-intercepts, gentlemen, my x-intercepts. Now, when it comes to plotting, you probably won't have much of an idea of where they are going to fall on your x-axis, okay? So it's a good idea at this stage to get a numerical approximation. And when we go to the plotting stage, we will indicate our x-axis using these numbers with the surds in them in exact form. Okay? But a numerical approximation, just so we can get our plot going, is x will equal 1.77 and I should say, because we're talking about intercepts here, and there are two of them, and 0.23, rounding it up a bit. Okay? They're our x-intercepts, roughly speaking. That's going to help us when we plot them. Okay? All right. What have I done? I've done y-intercept, x-intercept. Over here, I'm going to do the axis of symmetry. Now, the axis of symmetry can be found in two ways. It can be found as the average of your x-intercepts. That looks messy in this case. All right? Or we can use the little formula we have for that, which is x equals negative b on 2a. Nice and simple. Negative b on 2a, I'd encourage you strongly to remember that off by heart. Okay, so what does that come to? Well, x equals, we said b was negative 10, so negative 10 is positive 10, and 2a is 2 times 5. Okay? I might put the negative bit in there so you can see where everything's coming from. So that's going to simplify to the rather convenient x equals 1. It's most important you remember that x equals 1 is an equation of a straight line. This line passes through the x-axis where x is equal to 1 and continues infinitely in either direction. It is parallel to the y-axis. Okay? That's the axis of symmetry. Our fourth feature is the turning point, which I'm calling TP for short. Now the turning point is quite easy to find. What I do is I take the value for my axis of symmetry and substitute it into my original equation to find the y value. Remember, the axis of symmetry will pass through the turning point, otherwise your parabola wouldn't be symmetrical, and all parabolas are symmetrical. So that is telling you the x-coordinate, as well as being an equation of a line, it's telling you the x-coordinate of the turning point. Okay? So to find the y coordinate, we use this notation if we wish. We say we are substituting x equals 1 into our equation. It doesn't mean y times 1 or anything like that. It means we are substituting the x 1 in place of x in our original equation. So that's going to come to this. Minus 10 lots of 1 plus 2. 1 squared is obviously 1, so I've got 5 minus 10 plus 2, which equals negative 3. So my turning point is not negative 3, that's just the y coordinate. The turning point is 1, negative 3. And so I've found my 4 features. Now I'm ready to construct a plot of the graph. And I'd ask you to stop it right there. And so here's a plot of the graph we should get. You should spend a little time preparing your axes. Notice that I've gone from negative 1 to 3-ish here in the x direction. We don't want a scrunched up parabola or elongated parabola. It should form a nice standard curve. Okay, what have I got here? Well, we started with the y-intercept. Indicate it, please. Make sure it's clear to the reader that you know what it is. It's 0,2. I've indicated the x-intercepts. Now, on this software program, it doesn't do things in surd form. You would write those decimalised approximations as in exact form. An exact form means using surds, if in fact there are surds in your answer. It might not be. Okay, so that's the only difference to what you should be doing. There's the axis of symmetry. It is an equation of a line, and the equation in this case is x equals 1. F of x calls this a point of intersection. Well, really, in our context, it's the turning point I wish you to indicate. But the turning point will, the axis of symmetry will intersect the parabola at the turning point. Okay, so they're the essential features there. Okay, thanks. Let me turn it off.